For the next few minutes, we're going to take a look at some of the emissions from engines. We've already looked at how they function, looked at the combustion process, the different fuel properties, and so forth. And so all along, we've been talking about what happens in these engines and what might cause different emissions, especially in the combustion process. We saw how we could get noxious gases, NOx's, and carbon monoxide, particulate matter, all those kind of things. So we're going to go in a little bit more detail on that today. In this session, we're going to look at the EPA requirements and what they've done over the last few years to change what the emissions look like coming out of a vehicle, and we're going to talk about what techniques are being used to mitigate some of the emissions coming out of our vehicles. So first of all, let's take a look at the EPA requirements as they're laid out right now. And the graph that you see on the chart you see on the left-hand side there, that is a depiction. It was actually produced by Case International, major tractor company, to kind of illustrate what was going on. And it's kind of a complicated system when you look at the emissions requirements that the EPA have implemented. They've been phased in for different size vehicles. It's been different for over-the-road vehicles and off-road vehicles, and it's come in phases over the years. So these particular, the chart that you see here is specific to larger agricultural tractors, so from 174 horsepower up to 750 horsepower. So these are the big tractors like you see in the picture there would fall in that category. And the blocks there show you different amounts of emissions that are allowable. And there's the emissions requirements are really complicated. There's a lot that go into them. But the basic fundamental part that they're after are two things. They're after particulate matters and they're after the noxious gases, the NOx's. And so the blocks there that you see, the width of the block shows what is allowable in terms of the noxious gases, and the height is what is allowable in terms of particulate matter. So particulate matter would be basically carbon that is comes out of the exhaust. We'll sometimes call it soot. It's the black stuff that comes out of the exhaust, and is particulate matter that gets in the air. You can see how it's been phased in over the years. So, and it's in different tiers. In the United States, we talk about Tier 1, Tier 2, Tier 3. We get up to Tier 4. There's Tier 4B. There's Tier 4 Final. So there's a bunch of different stages of this, and you can see how each of those has been phased in. So there's a big jump between that Tier 3 that you see in yellow there and the Tier 4 and the Tier 4B. So that was a major deal back in 2011 up through 2014 to be able to meet these requirements. And basically EPA said if you don't meet these requirements, tested outputs, you don't sell a vehicle. And so the manufacturers had to comply with this. And this is about the time that I spent 6 months with one of the major manufacturers on a sabbatical leave. And it was interesting to look internal in that company and look at the amount of their resources in terms of research and development that were poured into just meeting these EPA requirements. So it was a tremendous amount of effort, a lot of people working on that to come up with some pretty innovative solutions to meet these requirements, and we've really resulted in extremely clean emissions. So the engines now, they put almost nothing out of them. So it's very interesting to see how that has happened, but it's also interesting to see how these regulations have impacted the industry in terms of what types of innovations that these manufacturers were coming out with. It's been more in engine innovation and cleanliness and so forth, and they've kind of had to waylay a lot of the innovations in terms of new products and new equipment. So that's kind of the impact that it's had on there. The other impact is very visible. So you look at that tractor that's in the picture there and that big canister on the left-hand side, that is the exhaust. And it's this humongous big can, and so that's been the other result, is that the methods to mitigate the emissions has resulted in a lot of equipment, a lot of big stuff that we need to manage on these machines. And so we'll talk about how we mitigate these and the different ways that we can go about doing that. So with the emissions, and we saw this a little bit when we looked at the combustion, there's a trade-off there. So if you think about it, you know, we were only using 30 to 40% of the energy that's in that fuel. And we looked at that combustion equation and how that's a perfect combustion. The only products are carbon dioxide and water. So the closer we can get to that ideal combustion, the cleaner the exhaust is going to be. So we're not going to have to scrub it and clean it or do anything to treat the exhaust if we can do a good job of right up front of burning the fuel and burning it efficiently. And so that's, you know, one of the philosophies is to go after that. But then you end up with this seesaw effect with the trade-offs that we always have with engineering. So if we have a high combustion efficiency, we're going to reduce smoke. But in the process, we're going to increase temperature. So that's the way we burn it better, is to get the temperatures up, get the pressures up within the engine. It burns the fuel more cleanly. But we talked about the fact that we've got this nitrogen that's in the air that we'd like to pass through the cylinder unfazed, but when the temperatures goes up, then that nitrogen and the oxygen like to get together and create these noxious gases. So that's the trade-off with saying, hey, let's just burn this stuff more efficiently. So the other idea is that, okay, let's try to reduce those combustion temperatures. So if we can reduce the combustion temperatures, we're not going to be as efficient, but we're going to reduce the noxious gases. So we're not going to have as much of these NOx's. So that's going to help in the emissions. That'll clean that part up. But then here's the trade-off again. We're going to have to deal with more soot, this carbon particles or the particulate matter that's in the exhaust. So there's a trade-off. How do we find the solution? What's the best way to get both of it done? And the EPA says you will do both. So you're going to get them both down there. So here's how they do it. Here's how they mitigate it. And the first thing that they went after, and a lot of the electronic controls that are on our vehicles, and we talk about CAN buses, and some of your other classes, you'll work with the CAN buses, you work with the electronic communications. All of our agricultural equipment now is networked. So we've got microcontrollers on every function on the machines. The machines connect to the implements that are attached to the tractors, and all this information is being passed back and forth. And part of the goal of that is to increase the overall efficiency of the vehicle. So not just focusing on the engine and what is happening inside the engine, but how's the engine interacting with the transmission and interacting with all of the other mechanisms and machinery that it has to affect down the stream, and how can we make all of that work more efficiently. So more efficiency we have, the cleaner that we're going to be, the easier it's going to be to handle the emissions. So that's what one of the innovations that really came out of this. That's had benefits in other parts of the industry as well, and other functions on these machines and over-the-road vehicles and automobiles and everything. So that has helped in a lot of different ways. But getting specific now with the equipment, there's really two major things that we do with the emissions to try to clean it up. There's what we call selective catalytic reduction and exhaust gas recirculation. So we'll look at each one of those. Let's look at exhaust gas recirculation first, because it's basically the simplest. So, and this is the strategy on that seesaw where we teeter back and forth. We want to reduce the combustion temperatures so we don't have as much of the noxious gases in the output. And so basically what we do is we take some of the exhaust gas that goes out of the vehicle, and we're just going to, or out of the cylinder, we're just going to recirculate it right back into the input. And so coming into the input, we have the clean air, we have the fuel, but we also have some of this exhaust gas, which is essentially burnt, spent gas, and it's essentially inert, so it's not going to react. So it's extra gas, extra material in there that's going to do a couple things. It's going to reduce the combustion temperature because it's not going to be as efficient. That's the trade-off. So it will reduce that combustion temperature, and it will actually absorb some of the thermal energy. So a lot of times what we'll do, and you see it in that picture there, that we'll actually cool that exhaust gas. So we do some technique to cool that gas off before it goes back through the input, so we're not running a hot gas back in. So now we have cool gas that has mass, has thermal inertia, and so it can actually absorb some of that thermal energy, and we can heat that up, and so that keeps the thermal energy from leaving the engine. It stays in the exhaust stream and goes on out. So a couple of different things that happen there to reduce that combustion temperature. Unfortunately, like I mentioned, it reduces the efficiency, it reduces the amount of power that we can recover from a cylinder of a certain size with a certain amount of fuel going into it. But we reduce the noxious gases. The other trade-off that does, when we reduce the temperature with the incomplete combustion, that's where we start to get a lot of the soot and a lot of the particulate matter, the carbon chunks, if you will, the flakes or dust that are going out of the exhaust. So how do we deal with that? Well, we can filter that. So usually with exhaust gas recirculation, when we recirculate it back into the engine, coupled with that is going to be a particulate filter. So we call it a diesel particulate filter. And these can be very simple. They can be as simple as just a filter, like an air filter, that the exhaust has to go through that captures all the stuff. And they can be, there's some that are a lot more complicated than that. So the image that you see depicted here has a little bit more complicated stuff. It actually has a diesel oxidation catalyst, a DOC, in line with that. So they're actually treating that exhaust gas that's coming out of there a little bit to make it more efficient in the filter. So the filter is usually basically a ceramic element that the exhaust gas goes through. The carbon will stick to that ceramic, and so it is not in the exhaust gas as it goes out. So now we got to think about, what do we do with this filter that is getting all this carbon in it? So originally, when we first started using these, they were replaceable filters that had to be replaced periodically. They were quite expensive because it's a ceramic filter, and so managing that got to be an issue. So the manufacturers come up with a technique where they can actually regenerate these things. And so it's a matter of essentially incinerating the carbon that's in there, and then it turns that carbon into carbon dioxide and ash. And so there's a couple of different ways they can do that, but a common thing that they do is actually inject fuel into that exhaust stream where it's really hot. They burn it really, really hot, like 700 degrees C, and it essentially incinerates the thing. So it's a periodic regeneration, and you'll hear that sometimes with these engines. They'll be sitting there idling, and you're doing something, and all of a sudden the exhaust will start to make a funny noise, and it'll get very hot. You know, they have to put heat shields and stuff around these to make sure that people don't get near them and they can hurt, because it is really high temperatures. But they'll burn that stuff off, and then it leaves the exhaust as just ash, which is just an inert element that's not going to cause any problems, and the carbon dioxide. So that's one of the ways they can handle that. So that's exhaust gas recirculation. So the process itself reduces the noxious gases, the NOxes, but it produces the particulate matter, so we usually have to use that in conjunction with the diesel particulate filter then to get the carbon out of it. So the second technique we can use is what's called selective catalytic reduction. And selective catalytic reduction says, okay, let's allow the engine to operate efficiently at higher temperatures. We know we're going to get the noxious gases out of there. Let's scrub the noxious gases. Let's go after them. So the process in the engine is going to produce less of this particulate matter. We won't have to deal with as much of the soot, and we'll just deal with the noxious gases. And so this is a catalytic process. It's a chemical process. And it involves an extra fluid. So you see the photograph on the upper right there. Vehicles that are using selective catalytic reduction, they have a separate fluid. It's called diesel exhaust fluid. DEF, people will say, that's kind of an industry term that they use for it. Some people, there's a common brand that was available early on called AdBlue. So you see some people talk about AdBlue instead of diesel exhaust fluid, but really that's a brand name. But essentially what it is urea. So it's essentially fertilizer. So it's a 32% nitrogen fertilizer. It's an ammonia base liquid. Now you can't just use fertilizer in the engine because fertilizer is not very clean. So the liquid fertilizers are to use that don't have the cleanliness that they need and the purity to be able to use in the engine. So the diesel fluid is a purified version of that, but it's essentially chemically the same thing. It's very similar to what's going on there. So that's the diesel exhaust fluid. So you see this blue cap, and so vehicles will have the green diesel cap typically, or they could be different colors, but quite commonly you'll see the green cap indicating that that's a diesel fuel, and then somewhere near that or at some point on the vehicle there'll be a blue cap, and this is for your diesel exhaust fluid. So when you fill up the diesel fuel, you also have to fill up this fluid. It uses it at a much lower rate than diesel fuel, so a lot of times you can fill up, you don't have to fill up every time. Every couple fill-ups you can put, you need to put some diesel exhaust fluid in. It depends on the size of the reservoir and what goes on there. So again, that's a catalytic process that essentially reduces, and you can see in the image there, it reduces the noxious gases. When I got noxious gases and carbon monoxide and everything in there, through the chemical process, the resulting should be just free nitrogen coming out of there. The carbon monoxide should go to carbon dioxide, so we're adding oxygen in there, and we should have water and whatever particulate matter is in there will go through, and we'll typically try to filter that, may have to filter that as well. So those are the two main processes that we use to clean up the emissions: the exhaust gas recirculation, selective catalytic reduction. Some manufacturers will exclusively use one or the other, but more commonly most manufacturers are using a combination of the two. So using some exhaust gas recirculation, using some catalytic reduction to reduce the noxious gases and so forth. And so again, you result in a very, very clean exhaust. You can almost operate these vehicles in buildings now, and you're not going to get the harmful gases and so forth. It's still not a good idea, but they're much cleaner than they used to be, and so that's the result of what the industry has done to us. So we have very clean emissions. We have increased the efficiency of how the vehicles operate, and that's what we got. So that's a little bit kind of an overview of how we deal with exhaust gases, the emissions, how we mitigate the problems, and that will do it for our sessions here, our modules relating to the engine technology in this class.